Alright, let's do a review of motion in one dimension. This is not a full lecture. I'm not going to teach everything again. In this review, we'll go through the main ideas used over and over: position, displacement, speed, velocity, acceleration, motion graphs, and constant acceleration motion. I will also point out the most common mistakes students make with motion problems and show you how to fix them. At the end, I will give you a simple plan for how to study this topic so it becomes predictable instead of confusing. Let's start with position and displacement. Position tells you where something is compared to the chosen origin. Displacement tells you how position changes. Displacement is not the same as distance. Distance only tells you how much ground was covered. Displacement tell you how far and in what direction the object moved from start to finish. Direction matters here, even in just one dimension. Speed and velocity are related, but they are not the same. Speed tells you how fast something moves, but it has no direction. Velocity tells you both how fast and which way. In physics, velocity is the more useful quantity because it includes direction. Two objects can have the same speed but very different velocities if they move in opposite directions. Acceleration doesn't mean speeding up. Acceleration means a change in velocity. That change could be a change in speed, a change in direction, or both. In one-dimensional motion, direction matters most. An object can slow down and still have acceleration. An object can move in the negative direction and still have positive acceleration. This idea causes many mistakes if direction is ignored. Motion graphs are a visual way to describe motion. A position time graph shows how position changes over time. The slope of that graph tells you velocity. A velocity time graph shows how velocity changes over time. The slope of that graph tells you acceleration. The area under the velocity time graph tells you displacement. These graphs are not pictures of motion, they're graphs of quantities. Many motion problems assume constant acceleration. This means acceleration doesn't change with time. Under this condition, the motion equations apply. These equations connect position, velocity, and acceleration and time. They are tools, not shortcuts. You should only use them after you understand the situation and define direction clearly. Here are a few things to focus on with motion problems. Always choose a positive direction before doing anything else. Write down what is given and what you are solving for. Keep track of signs carefully and use motion equations only when acceleration is constant. And always check if your answer makes sense for the motion described. Now let's look at common mistakes and how to fix them. The first mistake is mixing up distance and displacement. The fix is to always ask where the direction matters in that question. The second mistake is thinking acceleration always means speeding up. The fix is to remember that acceleration means a change in velocity, not just speed. The third mistake is using motion equations without checking direction or signs. The fix is to define a positive direction first and stick with this through the entire problem. Here's how to study motion in one dimension. Practice setting up problems without solving them right away. Focus on identifying direction, known values, and unknowns. Practice reading motion graphs and explaining what they mean in words. Redo problems where signs cause confusion. This topic improves quickly with repetition and clean setup, not memorization. That's a review of motion in one dimension. Not every detail, just the ideas you use again and again. Motion problems become much easier when direction and setup are clear.